Good day everyone and welcome back to the channel. In this video, we will be looking at laws of differentiation. So we're still on the calculus topic and we're looking at different laws of differentiation. So instead of using the first principle to derive, we're going to be looking at different laws or laws of differentiation to say. So without wasting any further time, let's jump straight to the video. So the first law is that if we're given f of x of a constant value, and let's say for example, or we're going to represent that constant value as k, if we differentiate, then the differentiation or the derivative of that value will be 0. So to further explain that, remember, what we're doing with a derivative is that we're trying to find the gradient of a certain graph at a point. So if we have a constant k, in this case, let's assume that f of x is equal to 4. Then we're going to have a straight line like this intercepting here at 4. And if we find the gradient, or from what we know or what we've studied before, we know that the gradient of a horizontal line is always 0, which is what this basically equates to. Remember, we're trying to find the gradient at a point. And in a horizontal line, at all points, the gradient will be 0. Okay? Because the change in y is equal to 0. Therefore, if I say change in y over change in x, this will always be 0 over change in x, whatever the value would be, and that equals 0. So it won't make much of a difference. So that's where this first law basically comes from. Remember, the gradient of a horizontal line is always 0. So therefore, the derivative of a constant will always be 0, because that constant represents a horizontal line. So that is the first law of differentiation. So the second law says if we have something like f of x is equal to x to the power of n, the derivative of that will be equal to n times x n minus 1 to the power of n minus 1. So, in other words, this n becomes the coefficient, or multiplies with the coefficient of x, which was obviously 1 since we can't see any coefficient there. And then we subtract the exponent where we have n minus 1. So an example would be, let's say for example, we had something like 2 to the power, sorry, not even 2 to the power. We have x squared. Then the derivative of that would be, this 2 multiplies the coefficient, then it's 2x 2 minus 1, which gives us 2 to the power of x. So that is law 2 of differentiation. The third law is similar to law 2, but the coefficient of x is no longer 1. Let's say it's k, and we have something like this. So the derivative now will be k multiplied by n x to the power of n minus 1. So an example of that would be, let's say we have f of x is equals to 2x squared. And if we try to differentiate that, we're going to have 2 multiplied by 2, which gives us 4 multiplied by x, 2 minus 1. And our final answer will be 4x. So, as I said, this law is basically the same as the second law. It's just that In this case, the constant is not 1. Sorry, not the constant. The coefficient of x is not 1. It's k. It's a bigger value. So that is the third law. So the fourth law assumes that, let's say, for example, we're given the sum of f of x plus g of x, or the sum or difference of f of x plus minus g of x. The derivative of this would be the derivative of f of x plus or minus the derivative of g of x. Plus or minus the derivative of g of x. So if we're deriving the sum of two functions, basically what we need to do is derive them individually. So we derive the first function and then derive the second function, and then we add them together to find one value. So these are the four laws that we're going to be exploring in this video. So let's jump in straight to a couple of examples to further understand these laws. So the first example that we're given is f of x is equals to x squared plus 4, and we need to find the derivative. So if we apply the laws of derivative, we're going to say f of x is equal to, and in this case, we're using the second law, which basically states that if we have something like x to the power of n, the derivative would be n x to the power of n minus 1. And if we do that here, we're going to multiply this 2 obviously in front of the x, and then we have 2x, 2 minus 1, and obviously 4 is a constant, and if we do derive 4, we're going to get 0. So our final answer here would be 2x. And that is the final derivative of this function that we're given. So now let's look at another example. So in the second example, we're given f of x is equals to 3x squared minus 9x plus 4, and we need to find the derivative. So we're basically doing the same thing here, where we derive each of these terms individually. So if we derive 3x squared, we have 3 multiplied by 2, which is the exponent x squared minus 1. And then here we have minus 9x 1 minus 1. And obviously if we derive 4, which is a constant, we're going to have 0. So if we further simplify this, we have 6x minus x to the power of 1 minus 1 will give you x to the power of 0. And from the laws of exponents, we know that x to the power of 0 is 1. So 9 multiplied by 1 gives you 9. So the final answer for that would be 6x minus 9. So in this example, we're given f of x is equals to 4 over x squared. And we're told to find the derivative. So the easiest way to find the derivative on this one, it's basically to first apply the laws of exponents, where we now, before we derive actually, sorry, let me just fix that. Before we derive, we rewrite that as 4 multiplied by x to the power of minus 2. So we're basically taking this to the top, and we're obviously changing the sign to be negative. So now that we have that, if we do derive, what we're going to have is negative 2 multiplied by 4, negative 2 multiplied by 4, x minus 2 minus 1. And if we simplify that, we have minus 8, which is formed by negative 2 multiplied by 4, and x to the power of negative 3. So that is the derivative. And if we further simplify that and try to leave that in positive exponent, our final answer will be minus 8 over x to the power of 3. So that is how we can apply the laws of exponents, obviously, to simply derive that value over there. So in this example, we're given this value over here and we're told to derive. So this is a notation that we're probably not familiar with, but essentially what we're going to do here is that the moment we start deriving, we just have to get rid of this dx. So before we derive, I will expand what's inside the brackets. So here I just have to say 3x minus 2, 3x minus 2, and multiply everything or FOIL everything out. And what I get when I do that, I get 9x squared. I'm going to fast forward here. I'm just going to simplify it. I'm going to get 9x squared minus 12x plus 4. So now from here, when I start deriving, I just have to get rid of the dx. So when I derive this, I have 2 multiplied by 9, which gives me 18. X 2 minus 1 minus 12 x to the power of 1 minus 1 plus 0, since I am deriving a constant and we know that it equals to 0 all the time. So my final answer, if I clean this up, I have 18x minus 12. So this is my final answer here, and that is how I derive that value. So it's just a different notation. I just have to get rid of this the moment I start deriving. So remember, you only get rid of it when you start deriving, while you're still simplifying what's inside the brackets. In this case, this step here and this step here, you don't get rid of it yet. You only get rid of it when you get to step number 3, where you're now deriving. So keep that in mind. It's just a different notation. The way you derive doesn't really change. So in the next example, we're given g of x is equal to 4x squared minus 6 all over x, and we need to find the derivative. So in order to find the derivative with this, the first thing we need to do is to separate those two terms. So it's by saying 4x squared over x minus 6 over x. And then simplifying each individual term. Remember, we haven't derived yet. So simplifying each individual term, and these two obviously will cancel, and then we have 4x remaining. And then here, what we will do is to take this x to the numerator. So now we have 6x to the power of negative 1. So now that is the value of g of x. The value of g of x here and here are still the same. They still have the same value. It's just that obviously they look different. So now we can derive. And it's way much easier to derive this. So to derive the first one, we know that we only have 4 minus x 6x to the power of negative 2. So if we simplify that, we have 4 plus 6x to the power of negative 2. And if we need to leave that in positive exponent, we're going to have 6 over x squared. So our final answer will be 4 plus 6 over x squared. So this is how we would derive this value. Our final answer would be 4 plus 6 over x squared. So the final example that I want to do is similar to the one that we just did. It's just that this one is obviously a bit more complex, but basically we do the same thing. Remember, with this notation here, we only get rid of this the moment we start deriving. But before we start deriving, we're going to simplify what's inside the square brackets. So we're going to rewrite that dx. And to simplify what's inside that brackets, we're going to separate the two. So here we have x squared over 3x plus. And instead of me writing that as a fourth root of x, I'm going to rewrite that as x to the power of 1 over 4 all over 3x. And to simplify this further, I have dx. And then here, these will cancel. I have x over 3 plus. And then here, we have the bases that are the same. So obviously, we just have to subtract the exponents. So we're going to have x 1 over 4 minus 1, all that over 3. So if we simplify that further, we can just rewrite this as 1 over 3x plus 1 over 3, and the final product of that will give us x to the power of minus 3 over 4. So if we simplify this here, we're going to get minus 3 over 4. So from here, we're good. And we can basically start deriving. And to derive this, we need to get rid of the dx. And here we know that our remaining value, if we derive the first term, which is this one, it will be 1 over 3. And then obviously this will multiply this value. So we're going to have minus 1 over 3 multiplied by 3 over 4. X minus 3 over 4 minus 1. So that looks a bit complicated. But if we simplify that, we have 1 over 3 minus, and if we multiply these, we have 3 over 12. Since 1 multiplied by 3 is 3 and 3 multiplied by 4 is 12. Or we can just cancel those out. And what we have remaining is 1 over 4 x. And if we rewrite this or add these two values, these two exponents here, we're going to have minus 3 over 4 minus 4 over 4, which gives us minus 7 over 4. So we're going to have to the power of minus 7 over 4. So to simplify this, we have 1 over 3 minus 1. And then we're going to take everything to the numerator, to the denominator. We're going to take the positive or the negative exponent to the numerator to make it positive. And what we're going to have is x to the power of 7 over 4. And the last step here would be us saying 1 over 3 minus 1 over 4, fourth root of x to the power of 7. So that looked very complicated. But if you know your laws of exponents and you practice how to derive, you will obviously get to that conclusion easy. So that is it for this video. If you have more examples that you would like me to work out, you can just leave them on the comment. And I'll try to make a video of those examples. But as I've already mentioned, that is it for this video. I will see you in the next video. Please don't forget to share, like, and subscribe.